This is for Year 12 methods. It comes out of the functions trial number 9, question 4b. 4a, c and d are done as separate videos. Okay, in question 4, I've got this part of a truncus. I've got a restricted domain of the truncus, and I can see how it's been drawn. I'll have an asymptote there at y equals 4, represented by this, and the truncus has been flipped. Okay, so part B, find the inverse function stating its domain and range. Okay, so the domain of m is negative infinity to 3, and the range of m is negative infinity to 4. So before I even start, I know that the domain of the inverse will be the range, and that's going to be negative infinity to 4. And the range of the inverse will be negative infinity to 3. So my range is going to go from all the way down here up to 3. Therefore, when I take my square root, I'm going to be wanting the negative square root, because I'm going to be wanting values that go down to negative infinity. So keep that in mind. Okay, so how do I find that rule? I have a rule which is y equals negative 4 on top of x minus 3 squared plus 4. To find the inverse, I'm going to swap them. So x equals negative 4, x minus 3 squared plus 4. Sorry, y minus 3. And I'm now going to solve for y. So if I move the 4 over, I'll have x minus 4 equals negative 4 on top of y minus 3 squared. If I swap this and this over, y minus 3 squared equals negative 4 on top of x minus 4. If I take the square root of both sides, y minus 3 equals the square root of minus 4 on top of x minus 4, keeping in mind that I know I want the negative square root, and y will equal 3 minus the square root of negative 4 on top of x minus 4. I'm going to leave it exactly like that. So the inverse of m will equal 3 minus the square root of minus 4 on top of x minus 4 as being my answer. I've already answered my domain and range, and the negative square root makes sense because for the range to go from minus infinity to 3, 3 is my maximum value, and then I'll be minusing something from it.